Welcome to part 3 of our workshop series on COVID-19 data analytics with Kubernetes. My name is Haghighi and I'm a developer advocate with IBM. If this is your first time joining us, this is a multi-part workshop series on building, deploying and managing microservices applications with Kubernetes and Openshift. These workshops are designed around an application that combines multiple containerized microservices for parsing COVID-19 time series data for the number of positive cases and mortality rates in different countries and regions. In this lab, we'll take a look at the key features of Kubernetes and why Kubernetes plays such a vital role in the world of microservices and modern application development. We will explore how Kubernetes and Docker complement each other when adopting microservices architecture. Later, we'll review Kubernetes core components and concepts, as well as showing you how our COVID-19 application will be deployed on Kubernetes. Firstly, I'll show you how to spin up a Kubernetes cluster on your machine, and we'll then dive into some basic tasks such as creating, scaling, and exposing applications with Kubernetes CLI tool. Later, we'll explore more advanced topics such as rolling out updates, auto-scaling, and crafting your YAML file for implementing various tasks. Here's a quick revision of what we've done together so far and how that fits into our learning journey throughout this course. In the previous lab, we containerized our application with Docker, and we ran it on Docker, and we explored ways on connecting our containers together using Docker. Here we will deploy our application onto Kubernetes, and also we try to run some basic tasks to manage our application with Kubernetes. As a reminder, all these steps taught in this course are generic and applicable to applications developed in any programming languages or platforms, but to simplify our journey and making it more use case oriented, our course is designed around this COVID-19 data analytic application, which are available from these GitHub repos. So go ahead and download them. We're going to use them throughout this course, and we also used them in the previous lab to build our Docker containers. I've already deployed the application on a single node Kubernetes cluster on my machine. In order to give you an idea of what we are going to achieve together in this lab, let's take a quick look at this applications running on Kubernetes. Before that, here's a quick summary of its architecture and components. Our application has been developed in Java and a Spring Boot framework. It provides us with a number of API endpoints for retrieving COVID-19 data per region and country, dates and periods. It comes with a number of containerized microservices, including data parsers for positive and mortality cases per country, and a user interface for displaying data and also invoking those APIs through a number of sample functions. As you can see in this slide, data is fetched from Johns Hopkins University's repo, which is an authentic source of COVID-19 data, and stored in our local data repository. Here are the sample API endpoints, as we'll test them out shortly. So now let's take a look at our application. Here we've got 3 deployments, as you can see here. One for the parser for the number of deaths, the other one is for the positive cases, and we've got another which is our UI or the front end. And we've got one part allocated, basically one replica of each deployment running. So we've got 3 parts in total. And then here are our services. Basically, we've got 3 load balancers in our Kubernetes, one per deployment. And we've got these port numbers basically allocated to each one of those deployments. And obviously, since we're using Kubernetes, a single node Kubernetes, in this case Minikube, we are using the master Kubernetes master IP address, which is 192.168.642. And as you can see here, we are connected. This is our Kubernetes master, and now we've got it on port 31331, and we are connected to 32523. Let's reset it and connect again, just for you to see. So this is 32523 for the number of positive cases. I'm going to go ahead and connect. So now I'm connected. Let's take a look at all data for the country. Let's pick Brazil, click load. Then here's data for the number of positive cases in Brazil. So up until 28th of July, we've got 2,483,000 over that number basically of positive cases in Brazil. If you want to take a look at it for for a specific for all countries on a date, we can go ahead and pick 22nd of July and take a look at all countries data for the number of positive cases on the 22nd of July, as you can see here. For instance, let's pick a country in this case, just in case to go back to it. Like in the New Zealand is basically 1,555 in New Zealand. And then if you want to look at a specific country, display data for a country on a specific date, I would basically go for New Zealand again, as we just saw it. So New Zealand for the 22nd of July, let's click load. As you can see, is 1,555. And then obviously you can go ahead and pick a period for data from the 22nd, let's say, to 27th for New Zealand. That's basically the data for the number of positive cases. There was only one positive cases between the 22nd to 26th. So that's basically our Kubernetes cluster with our applications deployed. So if I want to switch to the number of death, basically all I need to do is I need to change that to this port number now, 31052. So I basically reset, connect, and then 31052. Now we can go ahead and connect. So if we go again for the same sort of data that we looked at, display all data, and again let's say Brazil. Now if you look at the data, we've got 88,000 number of deaths in Brazil. So previously we looked at the number of positive cases, which was over 2 million, and now we are basically looking at the number of deaths, which is 88,000. And again, if you want to look at for all countries on a specific date, let's say 22nd, as we saw it before. So here's the number of deaths in different countries on the 22nd of July. Even if we go back again to the one that we checked before, let's take a look at New Zealand in this case. So there's only like 22 cases, death cases in New Zealand, and if we look at it here for New Zealand, only 22. And also we can take a look at it from the 22nd to the 28th. As we saw, there was only one positive cases added. So from the 22nd, and now we're going to take a look at the number of deaths. So the number of deaths has been 22 for the entire period. So that's basically our Kubernetes applications. We've got 3 microservices running within Kubernetes, so we've deployed them. So by the end of this lab, you'll be able to create new deployments for each one of these containers that we created in the previous lab, and you'll be able to expose them to make them available on IP addresses and port numbers to be externally available and accessible. So that was our application running in a Kubernetes cluster on my machine. Just to give you an idea about the overall architecture, so we have got 3 parts in our Kubernetes cluster, and those parts have different containers, Docker containers in them. One is the user interface, and the other 2 are running instances of data parser, one for the positive cases and the other one is for the death rates. And obviously we managed to interact with these parts using services that we're going to basically learn throughout this course. This is just the high-level architecture of our application and our pods basically in the Kubernetes cluster. So let's get to Kubernetes. Kubernetes is Greek for helmsman or pilot, hence the helm in the Kubernetes logo. Imagine a ship full of containers like in this photo, and the helmsman is to make sure the ship sails smoothly through the oceans, and despite all the tides and waves, it basically makes it to the destination safely. The helmsman orders his crew to evenly distribute the containers around the ship in a way that proper balance is struck. No one side is abnormally heavier, containers won't fall off, and the ship sails smoothly throughout the journey. Just like the helmsman, Kubernetes looks after a large number of containerized applications by orchestrating them according to the load and the available underlying resources, making sure our system achieves minimum zero downtime and our applications are always up and running. In the first and second labs, we learned about the advantages and motivations for moving away from monolithic applications and adopting microservices architecture. Here's a quick flashback. Here we've got a monolithic application broken down into microservices, and then there's a Docker container built for each one of those microservices. And let's take a look at what microservices architecture basically offers us. Microservices architecture addresses all of the liabilities that are inherent in monolithic applications. It basically allows different parts of our application to evolve on different timelines. They can also be deployed separately, and you can choose your technology stack for each microservice as it best fits the purpose. And you can scale your services dynamically at runtime, or let's say you can create individual instances of your services dynamically. But the most obvious advantage here is if any part of the application fails, the whole application will not necessarily become unavailable or unresponsive to the customer, because they are not designed and operated as a single entity like in monolithic architecture. In the previous labs, we broke down our application into several microservices and then containerized them with Docker and let Docker run them. So we converted our application into a multi-container application in order to remove that single point of failure. But here's the problem. Docker is running on a single host. And here we discuss why we need a containers orchestration platform like Kubernetes when moving from development to production. A multi-container application must run on a multi-host environment in order to eliminate that single point of failure. If one host went down, our orchestration tool can switch the load to another host. And we need to be able to create new instances of our individual services, microservices containers to scale accordingly. Or when one or more of our services need to be updated, or let's say we are adding a new service to our mix, the orchestration platform must be able to automatically schedule new deployments and create new instances of our containers with zero downtime. Kubernetes scales and manages our containers according to the available underlying resources on the host. So obviously Docker has a very good view of what's happening to our containers, but not our host machine, and that's what basically Kubernetes offer. Last but not least, Kubernetes checks our containers continually to make sure they're healthy and in case of any failure, it will take actions to reinstate our deployment, create new instances, or even restore the services. Now let's take a look at a deployment scenario on a high level, how we are going to deploy our application onto Kubernetes. So we broke down our application, built Docker containers. Deploying each Docker container will basically spin up a pod with its Docker container in there. Based on our deployment scenario and the load, each pod basically gets replicated, and that way you're making new instances of the Docker containers, and these pods are inside a worker node, which we are not showing them here for simplicity. So we first created a deployment and then scale our deployment accordingly. And the next step is to create a service which allows our applications to communicate with each other within a cluster, and also exposes our application to the internet and external networks. If the service type is a load balancer, traffic coming to the pods, traffic coming to our application will be directed to the pods accordingly through the load balancer service. Now let's take a look at Kubernetes core components. Pods. So pods are groups of containers that share the same compute resources and share the same network. They're also unit of scalability in Kubernetes. If a container in a pod is getting more traffic than it can handle, Kubernetes will replicate the pod in the node or to the other nodes in the cluster if needed. Deployment. The deployment basically controls the creation and a state of the containerized application and keeps it running. It specifies how many replicas of a pod should run on a cluster. If a pod fails, the deployment basically will create a new one. Nodes. Each cluster consists of multiple worker nodes that deploy, run, and manage containerized applications, and one master node that controls and monitors the worker nodes. Therefore, clusters are made up of nodes, each of which represent a single compute host, or like a virtual or physical machine. Service basically enables external access to a set of pods. It is an abstraction which defines a logical set of pods and a policy by which to access them. There are different types of services as we'll explore them later in this workshop. Labels are literally labels in the form of key value pairs that you can attach to your resources to locate them for running actions on them or getting information about them. And then finally, namespaces. You can think of namespaces as a virtual cluster inside your Kubernetes cluster. You can have multiple namespaces inside a single Kubernetes cluster, and they're logically isolated from each other. Now that we know the key components, let's revisit our deployment scenario, this time in more details to see what's happening under the hood. Firstly, we'll use kube control or kubectl or kubectl CLI tool to interact with Kubernetes cluster. Kube control lets you control Kubernetes cluster and its resources. Think of it as your magic keyboard to instruct Kubernetes from your terminal. Going back to our deployment scenario, we use kube control to instruct our master node to create a deployment based on the given container. Obviously, master node processes our request through the API server and runs a scheduler service that automates when and where the containers are deployed based on our declaration. So remember that declaring, our desired state, as we are going to get to it later. And then each worker node includes Docker and a software agent called a kubelet that receives and executes orders from the master node. Kubelet spins off a new pod for every instance of our container, and then later, to expose our application to the external network or internet, our master node creates a service to direct traffic to our pods through worker node's kube proxy component. So to wrap up, here are the key features of Kubernetes. automatically rolling out changes to a deployment and the ability to pause, resume, and roll back to previous version if needed. Automatic scaling and load balancing, and that means when traffic to a container spikes, Kubernetes can employ load balancing and scaling to distribute it across the network to maintain stability. Self-healing, when a container fails, Kubernetes can restart or replace it automatically. It can also take down containers that don't meet our health check requirements. Service discovery, Kubernetes can automatically expose a container to the internet or to other containers using a DNS name and IP address. And finally, provisioning local and cloud storage for your containers as needed. We will use Minikube to run Kubernetes locally, so go ahead and install Minikube from this link. All instructions are provided and it would only take a few minutes to download and run Minikube. If you're on a Mac, it is literally as easy as typing in brew install Minikube in your terminal. But what is Minikube? Minikube is a single node Kubernetes cluster inside a VM on your machine. By going through this lab using Minikube, you'll ultimately be able to use Kubernetes on any given Kubernetes flavor from major cloud providers. Now let's go ahead and get started with Minikube to spin up our single node Kubernetes cluster. So the first step is to start Minikube from terminal. It is as easy as saying Minikube start, and that would basically spin up our single node Kubernetes cluster using Minikube. So there are a few components like Docker, and also the hypervisor needs to initialize, so that takes a few minutes. But just for you to know that you can basically decide whether you want to use the hypervisor by default for instance for Mac is HyperKit. If you want to use VirtualBox, you can basically just add the options like --VM--driver VirtualBox, or if you want to basically limit the amount of CPU and memory basically that you allocate to Minikube, you can also define that as options after Minikube start. So for memory, that's basically the amount of memory in megabytes, and also you've got the CPU cores. So for instance, you could put like 3 or 4 depending on your system, and also you can define the Kubernetes version. The other good commands, useful ones that you're going to use is pause and stop. If you want to pause it, if you want to stop your Minikube, that's how you do it. Let's take a look at our Kubernetes Minikube. Okay, it's now up and running. So let's get some ideas. As you can see, basically says now kube control is now configured to use Minikube. To get some idea about your cluster and the cluster IP, you basically put kube control cluster info, and that basically shows the IP address for your Kubernetes master and also the kube DNS address. I haven't got any deployment, but if you want to check it out, you would basically say kube control get deployment, and that basically shows you the deployment. If you want the pods, kube control pods basically shows you the pods. We haven't got anything at the moment, any resources at the moment, so that's why it's not showing us anything. But like if you want to also look at the kube control config view, if you want to make sure what's your kube control basically attached to, and what cluster it is interacting with, you basically put kube control config view, and that basically shows you what clusters I've got my kube control CLI tool kind of configured with. The important point to pay attention to is that the current context is Minikube. Otherwise, I've got some clusters like the Openshift cluster on IBM Cloud and other places, and I also basically list all the clusters that you've got access to and you've already used in the past. But at the moment, it's using Minikube. Let's clear this. And also, if you are, for instance, using the VirtualBox, you can look at the information about your VM using vbox manage, show VM info. Those are like some extra tips in case you want to take a look at what's actually happening in case it's taking so much resources on your machine. If you remember from the previous lab, I told you about the eval and how you can basically set your environmental parameter to use the Docker daemon in your Minikube. We are going to do that now. So what I'm going to do now, I'm going to say eval, and so let's take a look at our images, Docker images. So these are the Docker images on my machine, but if I want to use Docker within Minikube, I have to set my environmental parameters. So eval $, and then Minikube, and then Docker environment. So basically what this command does, it basically tells your terminal to start using the Docker daemon within your Minikube, so we don't have to create our images on our machine, on the host machine, and then push it into Minikube. You basically use the same Docker daemon within Minikube, and that makes it easier. So now I'm basically going to set it up. So now if I say Docker images, now I get all this list of Docker images that I've got in my Minikube cluster, and that is quite useful for you. As you can see, I've got from the previous lab we've created a number of apps. So we are going to use the my app and my app dev and my app UI basically for the COVID-19 data processing. To create a deployment, also let's take a look at our containers just in case. Docker containers. List, forgot that one. So those are the Docker containers that I've got right now on my machine. Again, that's not important, we're going to take a look at it later, but they were up and running 3 minutes ago, and some of them are not anymore, but like those are the containers. So we are not talking about images. Containers are the images that are running, so as we had seen in the previous section. So let's clear, go back, and also Docker PS, another good command from the previous lab. The processings are happening at the moment, so these are the ones, the live processes. It's clear. So those are just Docker. If you want to get familiar with Docker, you can go back and take a look at it from the previous lab that we ran. We extensively went into Docker and what you basically need to learn about Docker for building your containers, so containerize your applications. We're going to basically create our application now. What I'm going to do is I'm going to use some of the Docker images here. So the ones that I'm going to use, I'm going to tag them. So Docker tag, let's use my app dev, and then version 4, and let's call it my app dev v5. Just let's tag it as v5 because I want to make sure that I'm using the same version for all my applications here in this lab. So I've tagged that one. Let's use the my app as well. So that's for the positive data for COVID-19 positive cases. The first one was for the death cases. Now let's tag that as well. And then my UI, I'm going to tag it again. My app UI. So we've got v4. I want to make sure that we've got everything on the same version. So my app UI through v3, v4, yes. And here it is. So if I now go for Docker images, basically gives us version 5, version 5, version 5. So you basically tagged it just for us, for our reference. We want to make sure that we are using the same version across board. So now let's create our deployment. Create, let's clear screen. Kube control, create deployment, and then we're going to basically label our deployment. So I'm going to call it my app deploy, and then we need to give it the path to the image or the image name basically. So here in this case I'm using my app v5 is the image name. If we were using the IBM container registry, like as I said, like in before, or if you're using other addresses or the tagging system that we are going to look at it in the next section, you need to put that tag in there. But here we've got my app v5, so I'm going to create a deployment, and here it is created. So let's clear our screen and let's look at some of the resources now. So get deployment. So we've got our application up and running, everything is ready, 1 out of 1. And let's look at our pods. We got our pod instance of that running, basically it's ready as well. So it was as easy as just using kube control, create deployment, and deploying our app. If you want to take a look at what's actually happening, kube control, get events, some of the logins, you can actually see that it pulled it and then created, started, and then killed it and successful. So some of those are basically for like 170 minutes ago, some of them are for 38 seconds ago, which is the one that we basically used, and that basically scaled up Replicasets, and this happened for us that basically we managed to get our application up and running. If you want to look at it in kind of with metadata, some kind of sorted in a sorted or ordered with based on the timestamp, you can use --sort -by and then metadata.creation timestamp to basically sort it in that order. So I'm going to use it now. So let's say kube control get events and then --sort by metadata creation timestamp. Let's just make sure got it correct. Just need to make this there, and that's it. So here it is. Now I've got everything basically sorted in the order of events. So 108 seconds ago this started, 9 seconds ago, and then it goes on, and you can actually look at all the events. So that's actually quite useful, just in case if you want to look at the events in order and sequentially, you can do that. Let's clear our screen. And also if you want to describe your deployment, go describe deployment, and then the name of deployment, my app deploy. So this gives us a little bit of more information about our deployment, which is quite useful sometimes. So that's the name of the deployment, the namespace that this deployment is based in, the creation timestamp, labels. Again, labels are quite important when we get to the YAML side of things, and how we're going to basically use YAML files to make changes and also create resources. And also the selector, the replicas is only one. At the moment we haven't actually scaled our application to have more replicas. Other important aspect, the image is based on my app version 5, and also you can see that we've got at the moment 1 out of 1 created. The other thing that you can basically look at it is the containers. So that's the name of the container, my app. So that's also useful sometimes when we are going to use set, basically when we want to update the rollout and update a deployment. So that's also useful, but just in case if you want, so that's describe deployment and then your deployment name basically. Let's clear our screen, go back here. So what we've done now is we basically use Docker daemon within Minikube, and we managed to push basically we managed to deploy our application, and now there is a pod, and that pod basically got our container inside. The way we've done it is as a developer, I communicated with my Kubernetes cluster. In this case it was the master node and the API server. The API server got in touch with the kubelet, and kubelet within my worker node created the pod or the instance of the application. One thing you need to pay attention to, because we are basically using a single node Kubernetes cluster, in this case Minikube, it hasn't actually got 2 nodes. So if you use any other Kubernetes cluster, you always have a master and a worker node, or more worker nodes basically, and sometimes you get to have more master nodes. But in this case we are only using 1 node, but this is just for illustration purposes. And we're going to get to it later when we are looking at the services, because you get 1 IP address for worker node, and then in this case we are going to use 1 IP address for everything. But just for you to know what the process, this is actually what is happening here. And also, if I want to roll out Replicasets and I'll also scale my application, in this case my positive cases, the parser for the positive cases, if I want to create more instances, like 3 more instances, I need to use the scale. And the way it happens is, as a developer, I basically communicate with API server, with the Kubernetes cluster, and then that sends messages to Kubelet. There are lots of other things happening. You basically communicate with the scheduler, with the control manager, with etcd to make sure everything is ready. We've got all the resources available, and then communicate with Kubelet to create more instances of our application within that node, and that basically adds more pods. So that's the process, and the way we do that is we use kube control, scale, deployment, and the deployment name or the label, and then the number of replicas. But just for you to see, what we've done so far, because our application is up and running, I'm going to use watch command just to show you what. Let's take a look at our pods first of all. Get pods. So we've got 1 pod running at the moment, and by using the watch command, I'm going to basically just schedule this refresh, kind of refreshing the screen with the number of pods available every 3 seconds. So control get pods, and that's going to basically keep showing me what's actually happening. And now if I go back down here, kube control, scale, and then my deployment, my app deploy, and then replicas, I'm going to use 4 in this case. So as we have it here, so I'm going to use 4. As soon as I press on this, cube, okay, and spell it right. So now it's the scale. As you can see, now we've got 3 more pods added on top. Now those 3 pods are up and running. It only took a couple of seconds for it basically become available. So we've just scaled our application from 1 to 4 instances. So that was quite interesting. Again, that's the desired state. We are basically telling Kubernetes that we want 4 instances of our application running, and this is always going to be the case until we make some changes. And just to get your replica sets, you can say kube control get rs, or you can just write replica sets, and we've got 4 desired and 4 current, as you can see. If I try to delete one, if I say kube control delete and then pod, I'm going to just delete one of these pods, see what happens. So that pod is going to be deleted, as you can see, it's terminating. But then as soon as that happens, Kubernetes basically adds 1 more pod to it, because we have set the desired state as 4 replicas, and the current is 4 as well, so it kind of keeps on going to reconcile between the current state and the desired state. So that was just a quick test for you to see. Let's go back in here. The other important command for you is the auto scale. So you can auto scale your deployment to define the minimum number of replicas and the maximum number of replicas, and the sort of CPU percentage that you want to allocate to your application. In this case, for instance, you can set it 1 as the minimum and 8 as maximum, and then the CPU is 80%. The difference between auto scale and a scale is the fact that auto scale basically works in a way that automatically scales it down for you to 1 replica, to 1 instance, when there's not enough load and your application is not getting hit. And when it basically gets so much hit, it basically goes back up to 8, up to 8 replicas or instances of your application. But when you use scale, always going to keep it at 4. For instance, in that case, that we've got 4 replicas. So auto scale basically works based on the metrics, and scale basically keeps it exactly at that level. So you can go ahead and create an auto scale for your deployment, and always keep it either between 1 to 8 replicas. And that's basically horizontal pod auto scaling. And when you do that, you can basically say kube control get HPA, and obviously we haven't got at the moment anything up and running. But if we do, then we're going to basically get that here as well. The other important point, if you want to look at your Minikube dashboard, just have to say Minikube dashboard and it basically brings it up. So you can see that you've got a deployment 100% healthy, your pods are healthy, your Replicasets are healthy. Also some important information about your deployment, about your pods, about your Replicasets, and about your services, things like that. So that's the sort of information you get from Kubernetes dashboard. With Openshift Web Console, that you're gonna look at it later in the next section, you get much more. You can run all the commands that we just tried from the kube control, from the CLI tool. You can basically do it from the console, and it makes it much easier for you to interact with your cluster. Let's go back here. I'm gonna stop my Minikube dashboard, and now what I'm gonna do is, if we go back here, we created our deployment. We created our replica sets, and also we talked about the auto scale. Another important point is the adding services. So what if you want to basically expose your application to the outside world, to the internet? And for that, if you want a user to interact with your application, you need to create a service, and that's basically called exposing, and then that basically creates a service. We've got different types of services. We're going to go through that shortly, but the way it works is you're basically instructing kubeproxy to basically send traffic through a service into your node and to your applications and to your pods basically. And the way you do that is kube control, expose deployment, your port number, and the type. In this case is a node port. We're going to get to the types shortly. Let's make that happen. So kube control, expose, deployment, my app, deploy, and then we're going to say the port is 8082. If you remember from the previous lab, we looked at, we basically set our parser to work on port 8082, and then the type in this case is a node port. So our port, type, and then the deployment. Once I do that, then I'll be able to access my application. Now so it's been exposed, kube control, get services. So this is my app deploy as a new service. It's a type node port. This is the cluster IP. We're going to get to this shortly, and here's the port for this service, the node port, and now the type, which is node port. What we're going to do, we're going to try to curl, we're going to basically try to ping our application just to see how it works. Given that we only got one node, a single node in Minikube, we need to use the Kubernetes Minikube IP address, and we looked at it earlier, cluster info. So I get this IP address. Let me just stop the watch command. Get the IP address. I'm going to just basically curl, and then the IP address and the port. In this case is this one. If you remember, we had this hello that basically just pings our application, hello world. So this application is now up and running, and we've got 4 instances of it running. So what we did here, if you look at it from here, is basically we've created node ports, and node port basically gives us access from outside the Kubernetes cluster into our applications, and then we've got the Kubernetes IP address that gives us access to the Kubernetes cluster, and that is because we are using the Kubernetes IP address because we haven't got any nodes in here. In normal circumstances, when you are using Kubernetes on different cloud platforms, this is the way it's going to work. Basically, you get your worker node, and there's going to be an IP address for your worker node. But in this case, we haven't got that one, so that's why we are using the master IP. The other important things that you can see here, we've got the pods. Just imagine if you want to actually interact with your application directly from inside the Kubernetes cluster and use the service ID, the service IP basically. What you can do is we can go back and SSH into our application. So if I go back here, you can see that we can basically SSH into Minikube, and then from inside Minikube we can use the node port or the cluster IP, and then the container port in this case, which is 8082, and also the port is also set as 8082, and then interact with it directly. So the way it's going to happen is I'm going to use this IP address, the node port IP address, and that basically gives me access directly within the cluster. So that's an important point to pay attention to, because with the other one, with the Kubernetes master, we are basically using the IP address for the Minikube, but with this one we are inside. The way we SSH is Minikube SSH. Now I'm inside my Minikube cluster. I'm just going to say curl and then use this IP address with 8082 and then say hello world. So it basically shows us that we've got different ways to access our cluster. That's the SSHing into Minikube is not recommended. This is just for testing purposes, just to show you what it's like for our deployment, for our service to have an IP address and also the port that we can access it from within the cluster. So that was that one. Let's exit our Minikube, clear our screen, and also I'm going to show you some commands here as well. Curl, let's use the IP address again, and then port. There's a difference between this node port and the type of service, and we're going to get to that shortly. So let's say get country data Germany. So that's all the data for Germany up until 27th of July, and the numbers were 207,112. So basically that's the number of positive cases in Germany until yesterday, again going back to our COVID-19 application. So let's go back here. So what we've done here, we created a service to expose our application, and that created a node port. So now let's go to the definition of a service. So when you create, the type of services we've got here is a cluster IP. This is a default type that exposes the service on a cluster internal IP, and you can reach the service only within the cluster. When you create a node port, you basically create a cluster IP as well. And what happens is it basically exposes the service on each node's IP at a static port. So the static port, you're familiar with that. So we had it on 30, for instance, 32.248 or 31.051, the one that we just looked at it. And then going back to our definition, so that's the node port. And the cluster IP service is created automatically, as I said, the cluster IP type, and the node port service basically will route to that. So you use that IP and then the node port to route to that one. And the way you use that is node IP, node port, exactly the way we just managed to ping our application. The other type is a load balancer, and load balancers basically exposes the service externally, and it basically needs a node port and a cluster IP. So that's why the external load balancer routes to your node port and cluster IP service, and it basically just goes one layer higher to expose your application, and it gives you an IP address to access your application from outside the cluster. When we talk about the ports, that's a different one. You have a node port, it's different from this port, node port, which is a service. This is a node port, it's a port, and this basically makes your application visible outside the Kubernetes cluster. When we talk about port, that's a port internally within the cluster. As you can see here, this is a port, that's a node port up there. And then a target port is for the port that your container is listening on for traffic coming to that pod. So as you can see here, our application for our data parser application is listening on 8082, and then the port, which is the internal within the cluster, the port internally within the cluster, that is also 8082, But also the node port that is allocated automatically, you can also define that one, but it needs to be available. It gets automatically allocated. That basically sends traffic to your port, and then your application is listening on that one. So this is just to clarify what we mean by the type of ports and also the types of services. So you need to pay attention to that one. But your target port is an important one, because that's exactly what your container is to be listening on. If you change that, then you won't be able to listen to traffic coming to your application. So I hope this one is clear now. So we've got a service, as you had seen, and we've got a node port type of service, and also we've got the port number, which is a node port, and also we've got what we're going to do next, we're going to create a load balancer. But before that, let's try a few things. We are basically going to use the load balancer, and the load balancer basically gives us one layer higher, that gives us the external IP address to access the application. So what I'm going to do, I'm going to delete my service. So control services, and then service, my app deploy. That service is deleted. Let's clear the screen, and now let's create a new service. Expose deployment, my app deploy, and then our port, it stays the same because we want to use 8082, and then the type will change to a load balancer. So that's it. Our application is exposed now. So Q control get services. So one thing that you can see here now, we've got this external IP which is pending, again because our application, our Kubernetes cluster is a single node running on our machine, so there is not a possibility for it to create an external IP address. If you've got this Kubernetes cluster running on a public cloud or another kind of cloud provider, you basically get this external IP address immediately, and that together with this port number, which is your node port, gives full access to your application from outside your cluster. Again, we can go ahead and test it out, just to see what it's like to use that external IP address and the node port to say hello. Let's go ahead and do that. So curl, use this IP address, because again we are using Minikube, that's why we're using this IP address. And then this port, this is a node port but for the load balancer, and then hello, we say hello world, and so we've got full access to this one, even though it's a type load balancer. And now if you want to use the cluster, if you want to again use it on a proper Kubernetes cluster on a public cloud or a private cloud, you've got this Kubernetes cluster IP, not the load balancer external IP, the one that's basically, we are basically using the Kubernetes cluster IP, but you need to use the load balancer external IP. So that's the difference here. So don't get confused. This is just for Minikube. And even if I try to SSH into my Minikube again, I can use the load balancer cluster IP, internal one basically, and the port, and say hello, exactly like we did last time. So it works exactly the same way, but obviously with the load balancer you get this external IP address. And the important point to pay attention to is that when you get the load balancer, it basically decides where to send the traffic. When it goes to your kube proxy, regardless of how many instances of your application you've got, it basically makes that decision and sends that traffic evenly, or based on different metrics, to make sure that your application is always addressing the requests coming from clients. And that it always refers to that as with your service name, with your service, rather than the IP addresses coming from the pods, because those IP addresses are going to change all the time. So every time you kill a pod and a new pod comes up, there's going to be a new address allocated to that pod. Not necessarily, but it happens quite often. So you're not going to use those IP addresses. Instead, what you're going to do is you're going to refer to your service with the service name. So again, this is something that we're going to look at in the next part with our Openshift cluster. So remember that part. Let's go ahead, and so we exposed our application and we tried everything. Now if you want to roll out updates, so updates basically allows your deployment to so basically rolling out updates allows deployments updates to take place with zero downtime. So Kubernetes intention is to make all those updates without causing any interruption to your application, and it tries really hard to minimize that downtime, as we call it, to zero, and bring it down as much as possible, and then incrementally update all your pods or your application instances with new ones, so it doesn't happen all at the same time, just to make sure that you got some pods up and running and the other pods are actually updating their containers, their image and containers. There is this concept of blue-green deployment. We're not going to get into that, but this is a very sophisticated process, and it basically makes Kubernetes stand out when it comes to rolling out updates, because in a microservices world you always want to roll out new updates to different microservices, your different containers, and that needs to happen sometimes quite often, and you don't want to interrupt your application or make your clients unhappy. What we're going to do here, we're going to basically replace the data parser that we've got for positive cases with the data parser that looks into the death cases, and that we're going to look at it how it's going to happen. Just to kind of illustrate that, we're going to run our user interface, and then that user interface is going to connect to one of these pods, to one of these applications, one of these data parsers, and then we're going to basically switch that to see how Kubernetes can make that update happen. And both of them are going to again run on the same port within the application, and then the node port is obviously going to be different, but the IP address in this case is going to stay the same because we are using Kubernetes master IP address. So let's go ahead for the application that we've got running now. Let's set the image. That's the way we do it. Kubernetes set image deployment name, and then the container, and then the new image that we're going to basically roll out. So let me just bring back our watch command. So watch and control get pods. So it's going to basically keep on giving us information about the pods. Let's clear this, and then kube control. I'm just going to remind myself of the Docker images I've got available. So the other one that we're going to use is my app dev v5. So let's get this one, paste it just in case. And now kube control set image deployment my app deploy, and then we're going to use the container name in this case is my app, as you had seen it, and you can basically take a look at it. Let me just show you very quickly before we do that. Control get deployment, and then write. So if you use this, you can actually see the container name as well. So the container is my app. So now I'm going to go ahead and make that happen. Just wanted to give you that information in case you get confused. You need to use the container name. Set image deployment my app deploy, and then the container is my app, and then the new image name we saw is v5. So kube control set image deployment container and the new image, and let's take a look at how it's going to happen. So now our deployment is being updated. You can see all the pods are getting terminated, but not all of them at once, and then very quickly is back on, and all of them is up and running. So if I query my application again, curl, if I remember, must be one of the, no, I didn't use it here. Anyways, control cluster info. That was the IP address. And then if I say curl, so we focus on the services file, I need to get the service. So control get services. So that was the service. So let's put it this way. Curl. And now 32.523 and hello. Connection fail. 32523 and 624. Interesting. Something is up. Connection refused. Fail. Command. Okay, let's see. Should get deployment. Our pods are up and running, no problem whatsoever. Control get services. Load balancer is also up and running, no problem whatsoever. 523. 32523. Oh, now it's up. Okay. It basically, so the reason for that is because JDK sometimes takes some time because we've got a Spring Boot application running. It sometimes take a little bit longer for that to come back on. So the JVM and also our Spring Boot on top of that. So that's probably because of that we didn't get any responses from our application. But the fact of the matter is that we basically just updated our image and our container was basically updated, and then the replicas were updated immediately after that. If I try to ping my application from a browser, let's take a look at it, see what it's like. And I'm going to say get country data and then Germany. So that's the data for Germany. If I want to see it in proper formatted JSON, I can just use this browser that shows me better formatted one. So as you can see now, we've got the data for Germany and it's 9,121. So this is the number of deaths. It's not the same as the one that we looked at back then for the number of positive cases. That was 200,000. So we just basically changed our image to look for a different type of data. Going back here, I can just do the same thing again, but I would say get country data Germany. And again, just to remind you, you had seen it before, it was 200, now it's 9,125. So from 200,000, which was the positive cases, now we're going to look at the death cases. Again, for the data science application, you can easily switch back and forth between different containers and different applications, and this actually brings a lot of flexibility. It's clear here. Go back to our slides. So I basically just set my image to a new image, and you've seen how basically went from positive cases to the death cases. If you want to undo that, is just kube control, rollout, undo deployment, and also you can define, this is optional, you can also define the revision. So here, if I say kube control, rollout, undo, and then deployment, my app, deploy. So just to remind you, here we looked at the number of cases, it was 9,000, so that was definitely for the 27th of July. Now if you go back here and then undo the deployment, it's going to go back to the number of positive cases. Let's take a look at it. So the application is now rolled back. As you can see, the pods are updating. Let's give it some time again, because last time we saw that it took a bit longer for that JVM to start again. So our pods are running. Again, if you had like something like Quarkus, it would have been much faster. We didn't even need to wait that long for that bit of time that it took for the application to start running. Again, we get that to that later in after episode lab 7 basically. So we're going to get to that and show you how you can use Quarkus to expedite or kind of make your application faster and also smaller. We're going to subatomic Java, so that is quite interesting. So I'm going to go back again, take a look at Germany. Oh, again, it's going to take some time for it to come back on. Let's wait. Again, it's a Minikube running on my laptop, so that's why it takes a little bit longer. But in terms of control, get parts, everything is running. We'll get services. As you may hear, the fans on my laptop is going crazy just because Minikube is taking so much resources. The services is also up and running, and it's the same 523, 22523. So it should be back on now. Not yet. Let's ping our application at least. It's still failing. Coming back on again. Yes, now it's back on. So now let's go and take a look at it. So hopefully you're going to get good results. So now we are back to 207,000, which is the number of positive cases, not the death rate. So that was a quick example again, just to show you how you can basically update your application and then also undo that rollout. And if you want to take a look at the rollout status, I should have shown you this earlier actually. So you can say control get rollout rollout status source status. Okay, we need to define deployment, then my app deploy. So rollout is successful. Also, if I want to take a look at the logs, for instance, I can just use control log /f and then deployment my app deploy. This is a much better kind of logging and monitoring, compared to what we had. So one of the things that I'm going to show you now, you can see why we had to wait that long, because JVM is taking some time for it to come back on. And this is exactly where you can see that data, because it looks into that deployment to see what's actually happening. As you can see, we've got the spring here, so the application was running. It was basically just taking some time for the JPA entity to initialize. So this is what's actually happening there. I can just stop this and just clear my screen. Now let's go back and do that rollout again. I'm just going to set the image again to go back up again. Where is it? Okay, so I'm going to basically set the image again to the number of death cases, and then we're going to look into the logs and see what's actually happening there. So let me do that. So image updated again. What I'm going to do, I'm going to use my control logs f deployment and then my app deploy. As you can see now, the application is running. So the pod is up and running. It's only the JVM that is taking its time, and a Spring Boot obviously in this case that is taking its time to come back on. So this was on purpose, just to show you what it's like when sometimes you wonder what's going on. So you can use logs basically just to look at it. And again, as I said to you, JPA basically took a little bit of time for that database to initialize, because we are basically pulling data from Johns Hopkins University, and then it goes into a JPA database, and then it needs to initialize, and that's why it's taking a little bit of time, as you can see here. So if I go back here again and start refreshing, obviously I'm not going to get any response from the application. But if we wait for it until it's over, then we go back there and you can see the application is up and running. But the pods are up and running with no problem whatsoever. So let me just stop this, and we're going to leave that log to go on just for us to come back to it later when it's finished. So that was the status also, so you can undo and you can also take a look at the status, but I give you one more command, which was the logs, which we're going to take a look at it in the next slide. Another important resource, basically, a concept, basically. So another way you can actually update your resources is to use YAML. And with YAML is a human readable data serialization standard, and you can specify configuration type information for files, for inter-process messaging, for cross-language sharing, and all those things. And if you want to compare XML, JSON, and YAML, that's down there in that table. It is quite simple. You just need to use the spaces basically to define where you are compared to with your keys and values. The structure of YAML is key value pair. You get array list as well, arrays and lists as well. You get dictionary and map, and that's basically how you can define it when you want to define your resources and your desired states, as we're gonna show you shortly. So some of the commands that I've used so far, I can easily just output the results of that command, or the response from that command, the output, into YAML or even JSON. All you need to do is like -o and then YAML or -o JSON. So let's take a look at it. Let's go back here. Okay, now our application is started. You see the started COVID-19 application. 99 seconds it took basically. So if I go back here, just to remind you, now it must be back on, and now we're back to 9,000. So we basically just set our application to use the number of death cases. So that was just for you to see what it's like. Let me just get out of here and clear my screen. Going back to our YAML definition, kube control, get deployment. I'm going to say my deploy, and O YAML. That gives me the entire kind of output in YAML. There's so much information in there. Sometimes the YAML file can be quite lengthy. What we're going to pay attention to is basically we're going to take a look at how we can use YAML file to make some of those changes, because what you get with YAML is, instead of like using a single command that is going to take a lot of time, if you've got like so many applications and so many updates needs to happen, you can basically squeeze them all in one YAML file and just apply the YAML file to get that information to make those changes happen on your resources. Let's clear our screen. This was just to show you what you can do with YAML output from all the resources that you query. But here, if you want to create a pod, and I wouldn't suggest doing that because creating a naked pod is not recommended. You can go ahead and use deployment, and deployment can take care of the pod, and then the Replicasets come after that. So but the format of the YAML file is what kind of object you're gonna you're basically trying to address, and then the data to identify the object. So here we are basically looking for this name of the application, and then the labels basically are important. Again, the app is COVID app, the specs, specifications, what states you desire. So with YAML file, the kind of format you get is you get the kind of object you're trying to address, then the data to identify the object, and then the state you desire. So for instance, for creating a pod, that's how you are going to create a pod. You basically define your containers and the apps, what the apps are going to be called, and then the container port as well. So that's basically the state you desire. So you're basically creating pods with these images, and you also basically attaching this, assigning this container port to it. And this is basically to identify the object, COVID data, and then the kind of object, which is a pod. If you are going to create a deployment, the same here. The kind is going to change to a deployment, and then to identify the object, to identify your deployment, that's what it's called. And then the replicas, you specify the replicas, that's the state you desire. Criteria for selection, so you are going to look for this app with this name. The matching label is basically the criteria here, and then the state you desire, basically you define your image and the container port, etc. The same goes for creating a service. The same thing that we did from the command line, you can actually do the same thing here from using a YAML file. For replica sets, it's exactly the same. And also for replicas with deployment. If you define the deployment and define your replicas, it looks for that deployment, my app deploy, and then we can define the number of replicas, and then it goes ahead and make that happen based on the image that you pass. Let's do that now together just to see what it's like. So I've got this definition already copy pasted in my YAML file here. So nano deploy YAML, I think that's what I called it. YAML. Okay, so it's exactly the same as this one here. I just need to change the label, basically the tag, from v3 to v5 because that's the one we are using. So in this case I had it from v4, put it v5. So all I'm saying is in here is basically create a deployment for me, call it my app deploy, and then you know, the metadata, basically this is to identify. So I'm not saying create a deployment, I'm saying look for this and then create these 6 replicas, and then this is going to be the image that is going to be used for that. And that is as simple as that. We can just like go from 4, as you saw, you know, in our previous example we had 4 replicas running. We can just easily go to 6. So I'm going to just close this. We just basically change that to 5, and what I'm going to do is I'm going to again use our watch command and 3 to control get parts. So you can see we've got it here, and then for that to happen, kube control apply F, and then the YAML file deploy YAML, exactly as we've got it here, kube control apply -f file name.yaml, and then as soon as I make that happen, you can see that now we've got new containers created. We've got new ones running with that image. One thing you should know, that the image is completely different from the one we had. We had the positive cases, we had the death cases because we made some rollout changes, and now it's going back to the positive cases. That's why we basically went ahead and destroyed all those pods and created new ones. So that's something you should pay attention to. If we had the same image, we would have just created 2 more replicas for us. So our application is up and running again. Let's take a look at it. 6 pods basically, but 6 instances. All of them are healthy and up and running. So again, that was quite interesting for you to see. My service is gonna hopefully stay the same, but I think it's gonna take time for it to come back on. As you know, our JVM is gonna take its time. But here's how you can make that happen using a YAML file rather than just running everything from your command line. Let's go back here and take a look at, you looked at the log. I mean, you can use L or F, again it depends, and also the container name. You can basically look at the container specifically, see what's actually happening inside the container, as we saw earlier with the JVM. And also the deployment, you can use that deployment description as we saw it in the beginning of this lab. So in this lab we basically tried most of the useful commands for Kubernetes, and we tried to create a deployment, expose an app. We basically pulled image from a registry in our Docker, and also we rolled out updates, created Replicasets again for the updates, and also used YAML to make those changes happen with the YAML file. Also we talked about auto scaling and how is that different from scaling, basically, just putting a scale. Again, that is based on the metrics of your application. I hope you have enjoyed this lab. It's been a great pleasure to go through this lab with you on Kubernetes. So this is the part that we finished just now. So we finished Kubernetes and Docker in this lab and the previous lab. The next part we are going to work on Openshift, and we're going to basically follow some of the same commands that we reviewed together for Kubernetes. but then on Openshift CLI tool, and then later we will use Openshift Web Console and show you how simple it is to implement or kind of make some of the things that we did just now happen in with a few clicks from Openshift Web Console. It is again quite simple, and you're gonna see that later. And also you're gonna get familiarized with the Openshift features and how Openshift is actually better than Kubernetes, and what sort of features you get more from Openshift container platform. I hope you've enjoyed this lab. Stay tuned and see you in the next workshop.